So what this means is the P means probability, and then A and B are two things that are happening. They're called events. So an event could be picking a card out of a deck or picking a marble out of a box. So what this stands for is the probability of A happening given that B has already happened. So we're going to write that down. This is new notation. That means the probability that A will happen given that B has already happened. All right, so then last week we learned about independent events and dependent events. So does anybody remember what independent events were? Yeah.
Wasn't it like it doesn't matter what the outcome is, and like it won't change anything?
It doesn't matter what the outcome is on the first event. It won't change or affect what's going to happen the second time. Good. So for example, if you flip a coin twice, it doesn't matter what happened the first time, heads or tails. The chances of getting heads or tails the second time are still 50-50. So when you flip a coin and then flip a coin again, those are independent events. What happened the first time doesn't affect what's going to happen the second time. All right, so if you have independent events, today we're going to find the probability of both of them happening. So this is the probability of A and B happening. And so the probability of both of them happening is, you figure out the probability of A happening, and then separately, you figure out the probability of B happening. And then something goes in between, and I'll tell you in just a second. So back to the example of a coin flip. Let's say A is flipping a coin, and then B is flipping a coin a second time. So we're trying to find the probability of getting tails the first time and tails the second time. So what's the probability of getting tails the first time? 1/2, right? Then what's the probability of getting tails the second time? 1/2. So then to get the probability of getting tails both times, you take the 1/2 multiplied by the 1/2. So what goes in between there is multiplication. So the chance of getting tails the first time is 1/2. The chance of getting tails the second time is 1/2. So the chances of getting tails both times is 1/4. Because 1 times 1 is 1 and 2 times 2 is 4. So you take the 1/2 and you multiply it by 1/2. And then that gives you the overall probability of getting tails both times. Okay? So that's if it's independent events. And that's true when you're flipping a coin. It doesn't matter whether you get heads or tails the first time. It doesn't affect what happens the second time. But sometimes it does affect things. So those are called dependent events. And an example of a dependent event would be you take a card out of a deck. Maybe you get an ace the first time, and then you don't put it back. Then the chances of getting an ace the second time are lower, because there used to be 4 aces in there, but after you take the ace out, there's only 3 aces in there. So those are dependent events, because what you get the first time is going to affect what you can get the second time. All right, so when you have dependent events, the probability of both of them happening. So the probability of A and B is the probability of A happening multiplied by the probability of B happening given that A has already happened. So since it's dependent events this time, you have to take into account that A has already happened when you figure out the chances of B happening. So a couple of new things today. First of all, this multiplication sign. You might not have known that if you want to get the chances together, you just multiply them. And then second thing, this slash. New notation on what that means. And it means the probability of B happening given that A has already happened. All right, so that gets us ready for the problems. So we're going to start with number 1. So in number 1, there's a box of pencils. And there are 5 green pencils. And there are 7 yellow pencils. And we are going to reach into the box and grab a pencil. And then we're going to reach in the box and grab another pencil. So there's 2 events. Grabbing a pencil the first time, and then grabbing a pencil the second time. And this time, we're not going to put the pencil back. So this is without replacement. So we're going to grab a pencil and not put it back. It's without replacement. And then we're going to grab another pencil. Okay, so the question is, what is the probability that they are both yellow? So the question is the probability of getting yellow the first time and yellow the second time. So first of all, are these dependent events or are they independent events? Does what you get the first time affect what you get the second time? Yeah, because if you take a green one out, there's less green in there, so that's going to affect the chances the second time. Or if you get a yellow one, there's going to be less yellow in there, so that affects the chances. Okay, so these are dependent events. So write that down. That's part of the answer. So the question says find the probability and also say whether they're dependent or independent. Okay, so since they're dependent, we're following this formula. So we've got to find the probability of getting a yellow the first time. So what is the probability of getting a yellow the first time? Yeah.
1 in 12.
Close.
Oh, it's 7.
7 and 12, right? Because there's 7 different yellows. Now, if you cared which yellow pencil you got, like maybe one of them has your name on it, then the chances of getting that one is 1 out of 12. But if you don't care which of the 7 yellow, the chances of getting any old yellow is 7 out of 12. So everybody okay with that part of it? That you reach in to try to get a yellow pencil. The chances of getting a yellow are 7 out of 12. Okay, so then you take, let's say you did get a yellow, and you're not putting it back because it's without replacement. Then what are the chances of getting a yellow the next time? Yeah, Judah? 6 out of 11. Good, because there's only 6 yellow left in the box, and there's only 11 pencils left in the box. So this is the probability of getting a yellow given that you got a yellow the first time. So try to get used to this notation here. This is the probability that you're going to get a yellow given that you got a yellow the first time. 6 out of 11. So you're assuming that a yellow happened, and you're saying, what are the chances of getting a yellow again? The first time, the chances of getting a yellow were 7 out of 12, because there was more yellow in there, and there were more marbles in there. Okay, so here's the chances of getting a yellow the first time. Here's the chance of getting a yellow the second time. Now, how do you figure out the chances of getting a yellow both times? What do you do here? Multiply them together. Good. So that's another new concept today. The chances of getting two things happening overall, or at the end, both of them happening, is the probability of the first one multiplied by the probability of the second one. So that comes out to 42 over 132. So I just took 7 times 6, and that's 42. And 12 times 11, that's 132. And then that will reduce, let's see, 21 over 66. Am I doing okay? Is 132 divided by 2 66? Somebody check me. Thank you. And then I think you can divide that by 3. It comes out to 7 out of 22 in the end. So the chances of reaching in and getting a yellow, and then reaching in again and getting a yellow, overall are 7 out of 22. Okay, number 2 is the same situation. We have a box of pencils with 5 green and 7 yellow. But this time, after we pick our first pencil, we're going to put it back. So this time it's with replacement. So are these independent events or dependent events? Yes, Alex. This time it's independent, right? Because it doesn't matter what you get the first time. Since you're going to put the pencil back, that's not going to affect what's going to happen the second time. So the directions say state whether these are independent events or dependent events, and then figure out the probability. So this time it's independent. So the probability of getting yellow and yellow is just going to be the probability of getting a yellow multiplied by the probability of getting a yellow. It's less complicated this time because the first event doesn't affect the second event. So what's the probability of getting a yellow the first time? 7 out of 12. What's the probability of getting a yellow the second time? 7 out of 12, because it's the same exact situation. And then to get the overall probability, you just multiply those together. So that comes out to 49 out of 144. Everybody doing okay? Okay, 14 is a little bit different. So let me write that problem down and we'll look at it together. This is 2m squared plus m minus 3 equals 0. And the directions say solve. So that means figure out what the m would need to be to make this come out to 0. So why is this problem not as easy as some solving problems? What makes this one a little trickier? Yeah.
Because the second m isn't I can't think of the word for
Isn't squared.
it. Isn't squared.
Good. So if both of these were squared, then that would make things easier because then you could add them together. Or if both of them were just m, then it would be easier because then you could just add them together. But when you have the letter squared and the letter, then it's trickier to solve. There's two options on how to solve problems like this. You can do quadratic formula, which I think you guys are pretty good at, and then there's factoring. So since I feel like you need more practice on factoring, I'm going to choose that option. But when you're doing problems on your own, you're allowed to use quadratic formula. All right, so the way factoring works is you put down two sets of parentheses. And to start out, we need that times that to be this. So 2m and m is what we're going to put down. And the reason we did that is because 2m times m is 2m squared. So we've set it up so that this is going to work out. All right, then we want these two numbers to multiply to be that. So what are two numbers that multiply to be -3? We just need a couple of numbers that multiply to be out to be -3. -1 and +3 is one option. Very good.
-3 and +1.
So those are the two options to multiply to be -3. Okay, now if there wasn't a 2 here, then we would pick the pair that added to be 1. But that trick doesn't work when there's a number there, like 2 or 7 or 3. So we just have to try and see what works. So I'm going to put -1 here and +3 here and see if that works out. I know that this works out to be that, and I know that this works out to be that, but I'm not sure about the middle part of it. So the way to check that is you multiply these together, that's 6m, and then you multiply these together, and that's -1m, and that adds up to be 5m. So I did this and this. Is 5m good? It's not, because we want just 1m. All right, so I'm just going to lightly cross this out because I don't want to forget that I tried it, but it's not working. So maybe I just put the 3 in the wrong place. Maybe I should have had the 3 here and the -1 there instead. It's still working out that that times that is that, and it's still working out that that times that is that. I just have to check this and this. So this is -2m, and this is 3m, and then that adds up to 1m. Is that good?
Yeah.
Yeah, because we want 1m. So that means this is the correct way to factor it. All right, then what do you do once you have it factored? You set this parenthesis equal to 0, and then separately this parenthesis equal to 0. So you write 2m plus 3 equals 0, and m minus 1 equals 0. Excuse me. And you solve both of those. So when you get done, you get -3 halves for one of your answer, and 1 for your other answer.